Hello, I'm just going to give you a talk through of a circuit I've designed called and labelled up as a dual 555 timer, oscillators with control voltage control. Here we have the two 555 timers set up as astable vibrators and a 9 to 12 volt supply. Across pins 8 and 7 of each chip we've got controls for a higher frequency and one for a lower frequency. These two capacitors on one each chip, one's lower than the other. It's all very experimental, this. There's no calculations written down, it's all done by trial and error. Sorry if my camera keeps going blurred. It's a crap camera. So that's pretty much a standard setup for a 555 timer. And they're running independently and chucking out the square waveform that they produce. This one's going to be putting out a fast train like that. This one's going to be putting out a lower frequency train. So what I'm trying to do is fire up a resonance speaker. It happens to be this value, 4 ohms and 25 watts, quite a beast of a speaker. And it requires quite a bit of pushing to get it to generate a good amount of sound and thump, especially if I'm going to put on my scooter. Should really build a dedicated amplifier for this thing that can take it to 25 watts, which is horrendously loud. Or 5 watts even. It's very loud. But I haven't done that. So I've done a temporary thing, and I've created this, what I'm calling a capacitive mixer. And it was just a random idea I came up, and I haven't actually seen it done in other circuits. So take the output of the first oscillator and the output of the second one, just two 220 UF caps, electrolytics, and pump the signal into each plate independently. But on the opposite side, the plates are co-joined, linked together, and they're pushing out onto this load. And remember, this is capable of this, so it's going to take quite a pushing. So I was just thinking, well, capacitors, the bigger the plate size, the more energy that's going to flow off it when you slam it from the other side with a pulse. All the electrolytics are polarized, there's energy on. And because of the nature of the circuit, there's going to be a voltage difference built up, especially when this starts running and these plates energize with each pulse of the train. So you can imagine this one here is bang, 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 bang. So it's going from 9 volts to 0 volts on that plate. It's suddenly 9, then it's suddenly 0. So when it's suddenly 9 volts, it pushes everything off the other side and into this bang. It's like that swinging ball effect, isn't it? That's the ball coming in from your bang into the next ball, and it transfers the energy through. It's pretty much the simplest way I could say it, and energy comes back and can bounce back the other way. It's a bit like a piston in some respects. And so if that one's doing a low pitch, bang, 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 this one's doing a higher one, ding, 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 bang, 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 bang. And they both just seem to mix together magically and push onto a common plate, pretty much. And I suppose if it's going to take the easiest route, so when that one pushes, it'll fill that plate up dead quick, and then it'll take the easier route and go that way. So it'll kind of block anything that's coming through that way, or will it? Because that's trying to push. This is, and they're in and out. You heard it on the experiments. This is just doing a mixing job very well, as it turned out. No real control of it other than changing the sizes of the capacitors. Smaller sizes, you'll get better high frequency response, and lower values, you'll get a stronger push but less capability to reproduce higher sounds. So there must be a balance point. But these are the highest I had on my kit, so I went with that. It seems to be working all right. You could easily feed these signals into another amplifier and power that up properly. Now the magic of the circuit is that you can alter the control voltage of pin 5, which a lot of people don't tend to use. It seems to be a bit of a mystery, but it's not. All you're doing is altering the timing sequence on one control rather than... It's a bit like a remote control, which is exactly what I need for my project. You set up your base sound and then you can tweak it with this, pretty much. You can carry on tweaking these and still tweak this. It's infinitely tunable. It's twin oscillators. So in my first experiment, I've just done this. A simple voltage divider that goes to the pin 5. Either makes pin 5 very positive towards the supply or grounds it down. And this alters the timing. Yeah. Pin 2 needs, if it's grounded out, sets off the timing cycle, and when it hits the higher voltage towards the supply, almost 2/3 the supply voltage, it flicks back the other way. If you fall below 1/3 of the supply voltage, it activates that pin, and anything above 2/3 of the supply activates that pin. It's sort of like a sensor. That detects high voltage, that detects the lower voltage. It's a window. And the control voltage here allows you to swing that window about a bit, hence speeding up and slowing down. So I'm going to try and refine it a bit further to try and take control of the window. So we know that 2/3 of supply voltage triggers one thing, and the 1/3 volts below shuts it down, slows it down. So by adding resistors here above and below, you're actually reducing. It means that you can't take this up to the full supply voltage and give it the full 9 volts, because it kind of crashes the timer and it sounds horrible. It's the same if you go too far to negative, it kind of screws the sound up. But actually, in just rethinking what I've just said there, grounding it out stops the timer, and you can get everything to slow down to a slow popping sound. So maybe this one isn't actually needed, but it's part of the experiments. Pick certain sizes of resistors. How, it doesn't matter how low you can go. I've already proved that you can pump 9 volts clean into the control pin and it doesn't harm it. So you've got 9 volts there. Depending on your value of resistance there, the voltage there is actually going to be 9 minus what of this. You could drop half a volt. There could be 8.5 volts available there to swing up to, and only 1 volt there to swing down to. Yeah, so you're now swinging in a smaller window. This is what I'm going to set up next and actually really try different values and see what happens to the sound with different values. Maybe keep this variable the same value and mess around with the window, voltage window. But that is pretty much it, Lady Peeps. Pause the video if you need to take a copy. Sorry for all the blurred bits, it's a crap camera. So that's a Dual 555 timer oscillator with control voltage control.